Good day, everybody. How are we all doing? Yeah, my name is Ali Adekule, and I want to continue with my calculus series on derivative. So last class we were able to deal with the product rule and the quotient rule. So I will continue the class by putting us through how to solve questions related to implicit function. So I'm going to be solving just three examples on implicit function before moving to the next thing. All right, so example one says x squared y minus 5x equals 3. When you have your x and your y written together in a particular equation, we say it is implicit or you say it is indirect. So to solve this, it's a very simple approach. What you just have to do here is looking at this place, we have x squared y. So meaning that is a two function, or let me say two variables are here. Meaning you have to differentiate x and y. But anytime you are differentiating y, you have to add your dy dx. That's the format. Anytime you are differentiating y, make sure you add the y dx to it. So if I want to solve this now, I will first differentiate the first one. You remember our product rule? That will be 2x. Keep the second one, that's y. Meaning that you will write your y. Then plus, keep the first one, that's you keep x squared, you will write into, differentiate your y. We have 1. But I thought that anytime you are differentiating y, don't forget you must put the y dx there. So the derivative of y is 1, then you have to add the y dx. Minus differentiate 5x now, that will be 5, equals differentiate 3. 3 is a constant, that will be 0. So we have 2x plus x squared times 1 is x squared dy dx minus 5 is equals to 0. So from this, now I just have to make my dy dx the Sobel formula by saying dy over dx will be equals to, this 5 can come here, that will be 5. Then this one also can come here, that will be minus 2xy. Don't forget we still have our x squared here. So x squared dy dx equals 5 minus 2xy. What we need is our dy dx. So you need to divide both sides by x squared, this one also by x squared. X squared will cancel x squared. We are left with dy over dx equals 5 minus 2xy over x squared. Our dy dx, when you have questions like y squared, x squared y minus 5x equals 3, our derivative is 5 minus 2xy over x squared. Even the question can continue further to say that what will be the y dx at a particular point. They can give you a particular point. For instance, this kind of question, I can give you at point, let's say point 1, 2. What I mean by that is anywhere you see x, you put 1. And anywhere you see y, you put 2. X comma y. X comma y. So meaning that once you get to this final answer, dy dx equals 5 minus 2xy over x squared. Just input your x equals 1 and your y equals 2. So that will be 5 minus 2 into 1 into 2 over x squared. That will be 1 squared. And that will be 5 minus 4 over 1, which is 1 over 1, and that's 1. In case they ask that, what is the derivative at point 1, 2? But if they not ask that you should look for the derivative at a particular point, you just have to stop here. Your dy dx equals 5 minus 2xy over x squared. So let's look at another example on implicit. Let's look at another examples on implicit. Let's look at another example on implicit. All right, so it's very easy. Anytime you want to differentiate y, just make sure you add your dy dx to it. Just make sure that you add your dy dx to it. Add your dy dx to it. It's a very simple thing to do. A very simple thing to do. Now, another question says, if you have x raised to power 3 plus y raised to power 3 equals 3xy, how do we tackle this? It's still the same format. Differentiate this, that's 3x squared, right? Plus differentiate this, that's 3y squared. But you need to put dy over dx because it is why they are differentiating. Now equals, let's differentiate this one. And this can be written as 3 into bracket of, you now follow the normal logic. Differentiate the first one, that's 1. Keep the second one, you keep y, you write y, that's the meaning. Plus, keep the first one, which is x. Differentiate your y, which is 1. But don't forget that I told you anytime you differentiate y, you need to add what? Dy dx. All right, so we now have 3x squared plus 3y squared dy dx equals 3 into bracket of 1 times y is y plus x dy over dx. So from here now, something is common here. 3 is common here. I can say 3 into x squared plus y squared to make the word work easier equals 3 into bracket of y plus x dy over dx. So 3 can cancel 3. We are now left with, sorry, this bracket should be covering this. You have to be very, very careful with bracket. It should be covering this, not x squared plus y squared dy dx. It should be into bracket of x squared plus y squared dy dx, not 3 into bracket of x squared plus y squared. You now close bracket, you put dy dx. So you have to be very careful with brackets. So we have x squared plus y squared dy dx now equals, we are left with y plus x dy over dx. So the next thing to do is just to collect the like times. Like, you bring the one with dy dx together. You bring the one with dy dx together. So from here now, I can see that, you can see that dy dx is here, dy dx is here. So we can just say y squared dy dx, okay, minus x dy dx equals y, then this x squared should go to the other side, minus x squared. So we can have y squared minus x dy dx. What I'm trying to do is I'm trying to factorize dy dx equals y minus x squared. So divide through by y squared minus x. This one also by what? Y squared minus x. Cut, cut. Then our dy over dx now should be y minus x squared over y squared minus x. So that's how to tackle it. And like I told you, if they give you any points, maybe they give you a point of let's say 2,1. So meaning that anywhere you see y, you put 1. Anywhere you see x, you put 2. We get it now. So it's very, very straightforward. Implicit derivative is very, very straightforward. You don't need to stress yourself about it. It's very, very straightforward. So moving on to the last example. Moving on to the last example. Moving on to the last example on implicit function. Moving on to the last example on implicit function. Moving on to the last example on implicit function. Sorry. Okay. Moving on to the last example on implicit function. All right. Okay. So anywhere you see y, please don't forget the logic. Anywhere you see y, you add your dy dx. So the last example on implicit function says if you have cos into x plus y equals 3, how do we differentiate this? You just have to be very careful. It's very, very easy. You just need to be very, very careful. Okay. All right. So now, if you remember, according to trig identity, if you have cos A plus B, it's the same thing as saying cos A cos B, right? minus sine A sine B. So we'll be doing the same thing for cos x plus y. We'll be doing the same thing for cos x plus y, meaning I can write it as cos x cos y, right? Then minus sine x sine y equals 3. Now let's start to differentiate. Differentiate the first one, that's cos x. And if you remember that trig derivative, if we differentiate cos x, we are going to have minus sine x. So differentiate cos x, keep the second one. Keep means you rewrite cos y. I'm using product rule. Then plus, keep the first one, that's cos x, right? Differentiate the second one. The second one is cos y. Differentiate cos y. That's minus sine y. But don't forget, anytime we are differentiating y, we must add what? dy dx. Then minus, let's move to the next one. Differentiate sine x. That will be cos x, right? Keep the second one, meaning that I write sine y. Plus, keep the first one, that is I write sine x. Then differentiate the second one. Differentiate sine y, that will be cos y. And you must also add what? dy dx, because we are differentiating with respect to y now. Equals, what's the derivative of 3? Is a constant. That will be 0. Right? So this can be written as minus sine x cos y. Then this is minus, right? So plus times this minus will be minus. So minus cos x sine y dy dx minus, moving on to the next one, that will be minus cos x sine y, which is this, then plus this. That will be that will be sine x cos y dy dx, and everything is equals to 0. Hope you are all following me. Everything will be equals to 0. Everything equals 0. Here, everything is equals to 0. So now let us try to open the bracket. We can write this as minus sine x cos y minus cos x sine y dy dx, right? Minus cos x sine y. Minus times this plus will be minus. So that's minus sine x cos y dy dx will be equals to what now? 0. So let's take the one of dy dx together and take the one without dy dx to the other side. So meaning I can write this as minus cos x sine y dy dx. I'm writing the one with dy dx together. Then we have it here too. Minus sine x cos y dy dx equals to, let me finish it here. Equals to, let's take the one without dy dx to the other side. This one has no dy dx. This one also has no dy dx. So let's take it to the other side. So coming to the other side, it will change to plus instead of minus. So that will be cos x sine y plus, this one also will come, right? That will be plus, this particular one will come to the other side. That's plus sine x cos y. All right, so I can bring out, minus is common first, right? So I can say minus into cos x sine y plus, because this minus will affect this minus, because I'm trying to factorize minus. They both have minus, right? So that will be minus cos x, minus into brackets cos x and y. Minus in this minus will be plus. Then sine x cos y dy dx. Please don't forget, I told you that the bracket is very, very important. And which is equals to cos x sine y plus sine x cos y. sine x cos y. So I believe we are following me very closely. All right. All right. All right. So from here now, we can divide both sides by this particular coefficient that we have here, the coefficient of dy dx. So we can divide both sides by that. So meaning that our dy dx now will be, that will be cos x sine y, then plus sine x cos y over minus into bracket of cos x sine y plus sine x cos y. So, and if you look at it, you will see that the numerator and the denominator are the same. They look alike, right? So this can cancel this. We have our dy dx to be equals to minus 1. So dy dx of cos into x plus y equals 3 is what? Minus 1. So it's very, very easy. You just have to follow the steps and understand that anytime you are differentiating y, you need to add the y dx. And understand the scope under product rule that says that you differentiate the first one, you keep the second one, that is, you write the second one, plus you keep the first one, meaning you write the first one and you differentiate the second one. All right. So thank you so much for listening. Do well to like, do well to comment, do well to share, and do well to what? Subscribe. Thank you. God bless you.